Welcome to Flat Earth United. I'm your host, Nathan Oakley, and if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a link in the info box and a super chat that runs alongside the show while it is live. Joining me this evening is Adam Meakin, who is a pharmacist and a co-host on Iron Realm Media. How are you doing, Adam? Good to have you here.
Great to be here, mate. Doing very well, thanks. Yourself?
I'm very well. Very pleased to have you here. Very perfect timing because we've been chatting quite extensively about curve calculations, and this is something that is quite near and dear to you. So maybe you can kick us off by telling us what your involvement with curve calculations is, Adam.
Yes. Yeah. Well, I start. This is kind of what got me into flat Earth. Was the thing I first looked at as a ball believer. So for a while now, I've been looking at ways of trying to produce a formula and went from incorrect formulas which didn't kind of compensate for the size of the ball you were working with to trying to explain it in terms of angular vectors, and I developed an equation which used an approximation to the proof of a sphere using an infinitely sided polygon, which was fine, but didn't allow the layperson to easily do a quick calculation equivalent to the 8 inches per mile squared. So that's kind of been my beef on and off whilst getting into all the flat earth stuff. You know what I mean? That's kind of been the side thing that's been niggling in my head over these 2 or 3 years that I've been involved with flat earth. So about 6 months ago, it kind of dawned on me a way of doing it. It was kind of looking at the way Bob on Globebuster was talking about the Sagitta and stuff like that, and kind of reversed it and turned it inside out. So that's kind of what led me to today, and hopefully what we're seeing is, and it appears to be fairly accurate even to the drop calculations of what Metabunk is using, is a formula that hopefully people can use quite simply without having a website, as long as you've got a cosine button, which as long as you've got a mobile phone nowadays is perfectly functional. You can hopefully use this formula to calculate the drop. And I suppose that's probably the key word at the moment. What is drop? So maybe I'll start the presentation and we can kind of get into drop and what I think drop, and how, if I live in the reality of living on a ball Earth, how gravity is the definer of drop and where drop is calculated from, and probably take it from there. What?
Yeah, perfect. I mean, if you want to bring up your presentation, that'd be absolutely perfect.
Cool. So the purpose of this presentation really is kind of just to show you how I derived the equation. So if you've got any questions of how the hell have you got to 6379 minus 6379 times the cosine of A multiplied by the distance, multiplied by 0.008326161, which is the formula. Kind of wanted to show people how I've got to that, so that if you've got any basic questions of why it is there, that it kind of explains before we get into any maybe more substantial critique of it, which I'm happy, because this is maths. This is about the mathematics of traveling on a circle, basically. So so it doesn't matter whether you believe it's flat or round. This is the mathematics of it. So
Or if you bring
I
up your
forgot
screen
share on this one. So
yeah,
screen share, we go.
Scroll your mouse over the Hangout, and then it's top left.
Yeah.
Top left-hand button is screen share, and then just pick the application. So there's 2 tabs: main window and application.
Lovely.
Let me know when you're there.
I'm there. Can you see?
Yeah.
First
you
slide.
just click hide on your little bar. There you go.
Do
Perfect.
so. Okay, so yeah, this is part of the presentation I first gave, probably back in the summer. Move on from that. So yeah, so basically this the presentation is just to kind of show you how we're going to make a curve calculator. So the first thing we're going to do is assume that the Earth is a ball of radius 6,371 kilometers. from that, what we're going to actually try to do is, and this is the first thing, is to try and use the mass of distance to try and calculate how we travel on a ball and how we can use that travel to generate some numbers that we can put into the equation. Excuse me. I want to define a mathematical definition of what drop is, which is what I was alluding to earlier, or curvature, which is created by the travel on this ball circumference. And then hopefully we'll use the diagrams that we can draw with logic to postulate a premise of a formula, use some trig a bit later on, which is really the only complicated bit of the thing. It's mostly logic, this. And then we'll combine all the assumptions we're going to make and the statements we're going to derive, try and combine them, and that'll put the curvature calculator together. So, like I said at the start, the first thing when I was thinking about this is how do we define distance? Because when we think about distance on a flat plane, we just draw a straight line. So the important thing here is whenever we're defining distance as far as being on a ball, it is actually the circumference of the ball that is defining the distance. So what I wanted to do here was use distance and try and calculate that and express it as an angle, and that angle being basically the distance traveled here. If you see, we travel from the North Pole to the equator, we would travel 90 degrees. So we could say, but what I wanted to express it was as just a kilometer. So in 90 degrees, there's 10,007 kilometers, we're told. So in 1 kilometer of travel, we're going to travel through an arc angle of 0.00899326161 degrees. And that's quite key in the formula, and you'll see that that's the big number at the end. And that literally is just so that we can turn the initial distance that we're trying to calculate the drop for as an angle. So I'd like to now make a statement or try and make a definition. So we can say that angle A, when we're traveling along a ball, is defined by the distance in kilometers multiplied by 0.00899326161. So we can see if that we traveled 1,000 kilometers, we'll be traveling, it'll be 1,000 times that, which will be close to 9, 8.99. So now we've got a way of expressing the distance traveled in terms of circumference. The next definition we kind of want to create is what drop is. And this was something I pondered on, not necessarily what the drop is, because to me it's quite apparent about how we could calculate that. And that's it. A lot of the stuff is calculated on the outside. What I wanted to do was stay on the inside of the ball and just stick with the ball and not space. So as far as I could see, once we've traveled this distance to here, for me, drop is, well, basically how much lower, if it was me at point 1 and I traveled to point 2, how much lower would my feet be than when I started? So that's kind of the way I wanted to define it. How much lower from a 90-degree eye line angle or spirit level or flat water level are my feet now after traveling that distance? And I think that's where there's probably a bit of debate, isn't there, Nathan, really, in terms of what drop is. But for me, it's actually the physical thing that has occurred. And we're measuring the physical movement across the circumference. Now, that movement we're going to express as a distance of the radius. And that seems to me the most sensible way when we look at the mathematics of trying to describe what the reality is the diagram we draw, that seems the sensible way of defining for me what drop is. So if we see once we've calculated angle A and we know the point of intersection with the circumference, we can draw a tangent straight across from the beginning radius, and that will then bisect the beginning radius, forming two parts, both D1 and D2, we'll call them. Drop 1, drop 2. And from this, we can make another simple statement that D1 and D2 is equal to the radius. We know that. And if we rearrange that equation, we could make a statement that actually to figure out D1, we take the radius and we take away D2. There is a point to this, and you'll see later, it's useful later. Now, trying to define D1 is actually very difficult to calculate mathematically. I struggled with, but actually, and this is kind of the thing that has occurred to me, that actually D2 is very easy to calculate. The point of intersection here, we've got a length radius here, we've got a point of intersection here, and we've got a known angle. And basically, we've got those factors. We can use trigonometry to define what we do. So if we use the basic SOHCAHTOA, we would define the radius here as the hypotenuse, D2 as the adjacent side. So we can know that cosine is equal to adjacent over hypotenuse. And if we put the adjacent and hypotenuse in terms of the terms that we're using within this triangle, we can make a statement that the cosine of angle A is equal to D2 divided by the radius. And I'm going to just quickly shuffle that one again, so it's a bit easier for me to use later on. So if I'm going to make the statement that D2 is actually equal to the radius multiplied by the cosine of angle A. So we're happy with the drop or curvature is D1. Hopefully now we're going to put all those bits of information together that we've defined, these being that D1 is equal to the radius minus D2. We figured out that D2 is equal to the radius multiplied by the cosine of angle A. And most importantly, at the beginning, the input information we want, which is distance, we figured out that angle A is defined by the distance we're trying to investigate, multiplied by a factor of 0.00899326161. So we're going to take those statements and start to just put them together a little bit. So we know that D1 is equal to the radius minus D2, and that's what we're going to work with and try and manipulate a little bit. Now, we also know that D2 is equal to the radius times the cosine of A. So if we just substitute that straight into the equation here and swap this D2 for radius times the cosine of A, we can make the statement at the top is actually D1 is equal to the radius minus the radius multiplied by the cosine of A. Now, as far as I'm aware this week, there's no need to change the size of the fictional ball Earth. It's defined as 6371. So for every calculation we're ever going to do with regards to the ball Earth, it's always going to be 6371. So we may as well put that into the equation because that's never going to change. So if we stick that in, we've now got that the drop 1 is equal to 6371 minus 6371 times the cosine of A. So I said at the beginning, we defined angle A as distance times 0.00899326161. If we pop that into the equation, we end up with the final product for the curvature formula for a fictional ball Earth. And the drop, as I would call it, in the curvature from the start point in kilometers can be expressed as 6371 minus 6371 multiplied by the distance being investigated times 0.00899326161. Obviously, a member of Iron Rail Media is Rob, and I set up a set of rules there which I'll probably go into later on, which is just basically how to do it on the calculator. And it's quite a simple procedure. You take the distance, you multiply it by that factor, you press the cosine button, you multiply that by 6371, and then you subtract 6371, and that'll give it you in the drop in kilometers. So if you're using small numbers, multiply it by 1,000, and you've got it in meters, and obviously another 100 if you want it in centimeters. There's one final bit, Nathan, and then I'll be quiet. And this was just for imperial reasons. Now it requires a little bit of extra recalculating of the formula, putting the numbers in from the beginning in an imperial way. And you'll excuse me here, I've stated kilometre, which Mr. Savage kindly pointed out to me, but it does mean miles. So in one mile of travel along the circumference, the angle, because obviously a mile is bigger than a kilometre, is actually 0.0144722858. And obviously when expressed in miles, the radius is smaller as well. So to have this is the equivalent formula for doing the same calculation in miles, which is 3959 minus 3959 times the cosine of the distance times 0.0144722858. And I'm finished, mate.
Perfect. There is one little element that you didn't have in there that's certainly on the Metabunk calculator, which is the actual observer height. So what would you do in your calculation if you wanted to, say, add 100 feet to the calculation in terms of observer height?
Yeah. For me, like I say, this maths was derived with no bias. It was derived to try and put the maths as close to describing the reality as I could. So for me, if I was stood, can you see the mouse? If I was stood at the original observer point and I'm looking at this distance here, then the distance is as defined. Now if I then manipulate this diagram, and you're saying, well, let's go to, well, let's say we're at the top of this stick and it's 1,000 foot. Now, the only difference I can see in the diagram in terms of how I would want to calculate, I don't need to change anything. As far as I can see, the mathematics is all exactly the same, bar I'm 1,000 foot higher from the beginning. But the curvature in which I'm going to calculate the drop from actually doesn't begin until here. So the height I'm at is irrelevant in terms of the drop traveled on the distance. So if it was me, if I was going to incorporate observer height, I would make the statement of calculate it like it is, because that's being calculated through expression of travel across around the circumference, and then factor in the other variable you're now putting in, which is that actually on top of that drop that you've calculated, you're also 1,000 foot higher. So for me, it would be my formula plus observer height will give you the drop if you're at something higher than sea level or something higher than the base of whatever you're observing.
So in essence, you just add it on.
Yeah, sorry. I could have put it simply, yeah.
Yeah. No, that's fair enough. I mean, it's one of those that in the Metabunk calculation, it's essentially bypassed by virtue of the camera being angled down towards the horizon, you know, in complete contrast to what happens in reality.
Well, that's the secondary confusion. That's what I've really enjoyed, particularly with Chris Monk's stuff, validating what we all know. Everybody's basic observe that when you look out to the horizon, you stand with your eyes looking forwards, and whilst over 1, 2, 3 miles, the angular variation is small. I think as you start to go to the tops of mountains and you don't start looking down. I've never looked down. You always look out, and the plains is an even more extreme example, isn't it? You're not looking down ever. You're still looking out. So for me, if I'm then relaying that into some kind of physical maths, then the point is a straight 90 degrees. It's a straight tangent from the radius that goes straight out. So for me, and I think this is another point you pointed out on the metabung, the only thing I kind of would like to discuss with people is, yep, I would come out to here and add it, but actually maybe we should be starting to think about here, to the point where you would intersect and see something. So that's the top point where you'd see something. I'd kind of drew it to there. You can see that now actually, because of the angle A, instead of it being straight up, and it's no longer again a linear relationship caused by the circle, you can see that the top, we actually, the taller the object, the further it gets away, the bigger angle A gets. So to me, whatever mitigate, there is a point to this, Nathan. The mitigating arguments that the ballers would give to argue with stuff actually end up making the number bigger, in my opinion. So I'm not that fussed. I'm quite happy with that as a measure, because, like I say, as you start to add more stuff in, even like with observer height, actually, from my logical observations, and I'm happy to discuss them, but to me, it makes it worse, and it makes the drop more and more significant as opposed to.
Yeah, quite right. It would be the same if you were in flight. As soon as you raise up, the distance travelled would increase if you were on a sphere. Simple as that. However, in reality, that's not what we observe. None of it is. I mean, we should probably point out at this stage that both of us are flat earthers, and while you are going to great extents to do the mathematics and demonstrate how it would work on a sphere, we don't live on a sphere. None of this matches reality.
No. And that's honestly, when you're trying to envisage this, that's the biggest trouble, because you're mismatching a mathematical model and you cannot observe it in reality. So it's very difficult and confusing, because reality and what you're trying to do or model isn't there for you to actually observe to model. And I think that's where a lot of confusion occurs. And so for me, this isn't the purpose of this really is for flat earthers and also for ball earthers to use in arguing. It's a quick way of doing it. It's the reality. If you look at, I think we used it in the week, we checked it in the week, didn't we, compared to Metabunk's actual drop value, and there's a very small decimal difference between these things. And I think, as you guys have showed this week, actually, certainly before you guys even started this, that was the definition that I came to on my own. And so for me, it's a useful tool for people to start to use in debate, and to be able to do any calculation to give them a real ball earth figure, if that makes sense, because 8 inches per mile is useless in terms of widespread debate across massive variance of things, and it's also not great early on. It's inaccurate early on, and if you were doing surveying over 2 or 3 miles, you'd actually want more accuracy than 8 inches per mile gives you. So
absolutely. Now, as I mentioned at the beginning of the show, you've got an association with Iron Realm Media, who you're due on with now, so I know you're under a little bit of time pressure. This might be cut short as a result, but either way, can you tell us a little bit about your involvement with Iron Realm and maybe your journey into Flat Earth as well?
Well, yeah, I mean, to be honest, mate, it was doing ball math formula. It was going through it, realizing, and it's kind of sending a plea out there in, I don't know, a long time ago. And then kind of just meeting up with John Savage. He was still, started on the gyroscope stuff, and particularly Rob, because Rob, although he might not sound it, is quite intelligent. And that's said in a very different tone to the way insults are thrown in your show normally, mate. I say, Rob's a good mate. And it was him that challenged me on my first maths and saying, trying to express it in terms of we have to build in the size of the ball. And so a good friendship was sparked up there with open, honest debate, nothing preloaded or anything. So started to chat with those guys. They were dealing with the guys in Canada, James and Walton and Josh in America. So kind of got in with them guys, and then it all kind of snowballed from there. We started doing our hangouts and started to be able to get a few guests on and made a few friends and got in touch. And the guys are now started to do that. Obviously, they've got the 2 slots a week on True Frequency Radio, so that's 10 o'clock Tuesdays and Fridays UK time.
Give it a full plug. Come on, you got to give it a proper plug.
I'm trying my best, mate. This is as good as it gets.
It's Tuesdays and Fridays.
The TFR shows, them two. It's the Ironworks, and it'll be those two just discussing current stuff, mostly flat Earth, but stuff that interests us flat Earthers in our lives and that. And then we'll have, obviously, like we do on Fridays, they tend to have guests on here and there as well. And yeah, an open forum. People are welcome in the chat and also to phone in. And really, another good thing, that it's actually the taking over. Well, not I did say that, but actually you can see a big influx of flat earthers as troopers into TFR. We're the following from Mark Sargent and Jaren's in there. Strange, we don't really, that we had Jaren on the other week. It's not like we were in there as through them. We actually got in there through Billy Ray, introduced the guys to Chris and the like. So it's coming in on its own merits, if you know what I mean. It wasn't coming in on the back of that. I mean, the other guys like a good bit of conspiracy and the likes, because Josh is there also on the Infinite Fringe on Sunday nights with Billy Ray Valentine and Bin Hamin. So that's a good old, more traditional conspiracy mashup, more 9/11 based, if you see what I mean. So a good mix, mate. But we're basically 6 middle-aged, bordering towards old men just giving our opinions. Do you know what I mean? And that some people like it, some people don't.
We were lucky enough to be on with you guys on both Iron Realm on YouTube and TFR, and it was a lovely experience. We had all 4 of us from QED did both shows, and certainly while you had Jaron on the Iron Realm show, we were sort of sat on Skype chatting away in preparation for the show, and then we got to obviously come on and chat with you guys and Jaron, and it was lovely. It was a really nice experience. Same goes for the TFR interview. It was a new experience for me, but maybe you can tell the audience a little bit about what TFR actually is, because there may be people out there that are totally unfamiliar with what True Frequency Radio actually is.
It's exactly, well, as far as I'm aware, it's a radio station, and it's quite well syndicated across other smaller and regional channels as well. So it gets quite a decent audience. So, for example, I think the Ironworks show's got sort of 3,500 listeners live, which is from our YouTube figures of great figures of 30 on a live show, up to stuff like with you guys. I mean, they were record-breaking figures, mate, when we had you guys on, over the hundreds and stuff like that. So the good thing for us is we're getting that flat Earth message out there to a much bigger and more varied audience. We're not necessarily speaking to a already converted or already antagonistic audience, if you know what I mean. But yeah, so TFR is just a big mainstream sort of truther, conspiracy, open platform for people. I think Chris and Sheree I've heard no restrictions from the guys in terms of what we can and can't say. We certainly tend to try, like yourself, keep the language and poor language down to a minimum. I've got no problem with an F and a Jeff here and there for exemplifying purposes, but certainly standard pub language we try to keep out of the live shows and that, just so that it's. I'm proud of what I do, and I'm happy for my children to listen to what I say and do. Do you know what I mean? I would like them to listen to it, because listen to your stuff. It's hard would be to get them to listen to your kids' stuff. You'd have to bleep out every time a baller came in, and I think that's a shame, because I don't tell my kids what to think. I want them to think for themselves, but I do want them to listen to both sides. And it's a shame that actually the quality of debate in your guys' show was was spoilt by the childishness and the inability to think critically and debate. The lack of debating skills, unfortunately, on the ball, as wasn't there, which is why it reverted to that. And I think it's a real shame, because a family show for us is not, it's not about being prime time, but it's about being civil and giving validity to what you're saying, rather than trying to necessarily just dominate the air to an end. You know what I mean?
That was certainly what I got the impression on both the TFR and Iron Realm shows, was that you weren't fighting for airtime. You know, everyone was very courteous. You got all the questions in. Everyone got an opportunity to speak. It was just nice. Whereas you are definitely fighting for airtime on the debates. You know, there's no pause for thought. If you try and take a breath, someone will take the next sentence away from you. So it's a very different feeling when you're doing those sorts of shows. Can you tell us a little bit about some of the guests you've had on?
Oh yeah, well, obviously we've not. Obviously last week we had Santos, which started out quite well, and then I'm not sure, something happened that upset Santos, and he left the show. That was last week. But obviously, as we said before, we had, when you guys were on, our biggest live audience ever, and Jaren as well. It was quite a main line for the Flat Earth community. So we a couple of weeks before, we'd had Jaren on again. I think over the past year or so, we've had ODD, Mark Sargent. So probably name a few. I'd say yes or no, but so lots of flat earthers, but also, you know, like I said, we do look at other stuff. So Walt doesn't interest me, but Walt and the guys had guys on that are looking into cryptocurrencies and things like that. The one that really interested me, Nathan, was a Canadian comedian called Alan Park. And he was diagnosed with stage 4 prostate cancer, spread to his bones everywhere, and, you know, was basically told go home and die by the medical profession. And we had him on and talked to him about his treatments with cannabis oil, and how it's led him to, you know, recovery and to be cancer free as far as he can tell. An amazing story. And yeah, quite privileged, mate. You know, just this kind of coming together as an individual. Without Flat Earth, I'd have never got on this journey and met amazing people, you know, particularly amazing people like that. And met Billy Ray Valentine, talked to the wrestler Bin Harmin, gave him a ring call. It's good fun, mate. I think it's a good community out there. There's a bit of sadness sometimes, but it's a good community out there.
Yeah, I think I totally agree. On the whole, the people in the Flat Earth community tend to be critical thinkers and a bit more open-minded on the whole. You do get some people that are conspiratorial, shall we say, to be kind to them. But, you know, that adds a bit of spice to your life. You know, it makes your life a bit more varied in terms of things that you can look at and maybe critically think about, rather than just seeing the general mainstream dross that comes through on a television set. I mean, I don't watch television anymore, and this is something that is a direct consequence of Flat Earth. I mean, there's been periods in my life when I've not watched TV, but, you know, as a very conscious decision, I've got rid of it. And life is better without it. That's the bottom line. I might not be Mr. Current Events anymore, but, you know, you don't necessarily need to be when you figure out that most of it's nonsense to begin with.
Yeah, I think the only news I like is a bit of Sky Sports news, mate, because I can't give up on the sport paradigm. I know it's the new cathedrals. I know what they're there for, but I love the punishment that Nottingham Forest give me. So, you know, I'm not even chasing glory, mate. But that's the only kind of mainstream thing. Certainly TV. Might watch the odd cooking program. But yeah, I've kind of disconnected from that kind of. And that was before Flat Earth, mate. I think there's a lot of us that were waking up well before. Say, I was told I was on a kind of common law protest with some guys, and, you know, looking at me, calling me the gig that I am, which, you know, I'm happy to be, and said, I've got one. You know, it was a guy called Kai Holloway, who's a top bloke, and it was him one night, just kind of thought he'd mess with my head and challenge me, and, you know, just said, look into Flat Earth. And like I said, I went away like most smug, well-trained and well-educated folk, you know, at degree level. And like I say, teach I teach GPs, I teach postgraduate, and I say development of future graduates as well. So very well cocksure, and it is, and this is why I struggle sometimes, mate. You know, when I look at these intelligent guys on your things, that I went into it with intellectual honesty, and what you've managed to demonstrate over these ridiculous number of episodes is that actually they're very, very intelligent guys with great, but actually they struggle because you can see that they're having to not be intellectually honest. And the one that struggled the most was Rumpus, wasn't it? Because he is intellectually honest. He did seem to be he struggled to lie about facts. The others seem to be quite happy to pervert stuff. And I know that's a generalization, and I'm not doing a thesis on the analysis of Nathan Oakley's chats. Do you know what I mean? But as a generalization, I think that was it's another sad indictment you've revealed about, for me, the scientific approach from the two sides. That there is a scientific approach one side, and God knows what you describe the other. Religious fanaticism.
Yeah, I'd definitely call it religion. I mean, someone like the Rumpus, I know we discussed this again on Iron Realm, but your first question to me was, do you think eventually he'll come around? And it's like, well, no. He's looking for the answers. I mean, I think probably right at the second he's doing a, quote, 45-minute presentation on refraction. So, you know, he wants to come to the point where he can square that circle in his own mind. And when he does, he's happy. That's him satisfied. So he's not going to, you know, if there is a heliocentric smear of bullshit to be found, he'll find it. He'll smear it on his sandwich and gobble it down. And then that's him totally satisfied. So yeah, I don't think people like the Rumpus are ever going to be converted. You know, they'll probably hang around things like the debates, and if they're in terms of things like the curve calculator, that is the heliocentric smear of bullshit. You know, the adaptation that's been changed in terms of the graphical representation of that curve calculator is what a lot of people will just go to by default when they come into this subject. They'll go to the Metabunk website, see how flat Earth is debunked, look at that diagram, and draw the conclusion that all is dandy, all is well.
Yeah. And that's another great example of the intellectual dishonesty. We'd planned this chat for a couple of weeks now, haven't we? And 2 weeks ago, mate, I would have been having a much different, more detailed chat using Metabunk's original pictures to try and explain why mine was so different and why this creation of a hump can't happen. He's still trying to create a mystical hump, but from nowhere now, because he's been caught out, and as I think it was this afternoon, wasn't it? As Chris demonstrated, as you tilt the camera angle back, you can't create a hump. The hump is created by looking through the Earth. The point that, as you say, you argue for quite a while with the 200-foot high wall of water. They couldn't get. For me, that was one of the more frustrating aspects of listening to the debate, as you guys kind of let them stick with that concept that there's water in front of them mounding up above their eye line, and then the world curves down afterwards for some reason. And that was the crucial part of my maths, is it's based on gravity. If a ball Earth exists, it has to have gravity, and gravity has to define the highest point. There is no point that can be any higher. There can be no hump. And it's impossible to draw one without, like you say, making somebody look through the Earth. And that's not then representative. I think Chris Monk's stuff probably explains it graphically better, but in no way do what they're showing represent what is happening when you observe. And that's why I would disagree with even the revision, even though we've stopped tilting backwards to create a horizon point, which means we angle ourselves back even
No, we haven't. I mean, all they've done is they've taken the target and angled that backwards. So the target is very much still angled away from you. That's why you had the example in your mathematics where if the building is tilting physically, literally in their depiction, physically tilting away from you, it increases the distance. Well, that's only necessitated because they've just changed it. So instead of the target being correct in their old diagram, they had the whole thing tilted such that you couldn't notice, or it was less noticeable that you're literally tipping back on your ankles as you're looking further and further at distance. And most people don't get this concept. The hump that you're describing, the wall of water, I still get criticism for it now. So at the 51 mile marker or whatever it was like 1,000-foot wall of water. And that was what obviously I'm going to pick, I think it was more than that. It was like 1,200 feet or something like 1,230 feet. But nice round figure is 1,000-foot wall in front of you, so that people can hopefully cement the idea that what they're looking at, in the pictures at least, physically isn't there. It's a representation of something that physically you don't have line of sight with. And most people really struggle with this. The ballers are the people who are struggling with this. So I'll say, well, it's a holographic projection of something that is not there, because it's 1,000-foot wall that you cannot see through. So in order for it to be there, it's physically being projected up from behind a curve. It's not there. But people don't get that. They're like, why do you say it's holograms? It's like, I don't say it's holograms. That's ridiculous. I don't think this is true at all. I don't think we see holograms of stuff from beyond curves. That's preposterous. But that is what you must accept if you want to believe you live on a ball. But getting this through to people when they just look at a picture of like a lighthouse that's just there, they go, well, what's the problem? There's a lighthouse, I see it. You go, yeah, but you shouldn't. It's not really there. But they don't get it. So it's a tricky one to have such a good an image as the Isle of Man when you've got all this stuff right down to the shoreline. But for some people, there is such a big cognitive break that they can't get that it's not there. They don't understand. For me, it's just funny now. It's it's got beyond the point of I just call them fantasists. And they're like, well, how do you get away with calling people fantasists when you're pointing out an eye-level horizon? You're like, well, because you must be. I'm just looking at a picture of something. Just say what you see. Whereas you have to have this huge, farcical bullshit sandwich that you've gobbled down and then regurgitated in order just to look at this picture. The ball Earth makes no sense. It's not the world we live in.
No, I agree. I think I'll obviously be listening. I'll listen probably to the Rumpus's explanation tomorrow to see if. And this is the trouble, you see. In a real world, we know he's going to go away and frantically try and number crunch to try and get somewhere near it. But it's kind of a moot point, because natural science should be pretty obvious. It's pretty obvious, as you say. I see it because it's in front of me. It's not arched down. It is in front of me. And in all of the debates, there really hasn't been any solid scientific evidence to mitigate for the refraction that they're talking about. And certainly you might get away with it over a particular light beam, but to suppose that from the sea to the sky you can project an image in perfect proportion and clarity, and that also, what you also think is, well, that's not a slideshow you're doing, because you've demonstrated over the shows this lighthouse is here and this bit's here and this bit's actually another mile and a half inland, but it's higher up, so it's level with this. Actually, that the complexities of the image that is being refracted is coming from multiple distances. For it to hold that image together just seems preposterous beyond belief. I could quite happily, given the possibilities of the mathematics working, let's say for a single light beam, believe it. But to resolve a full image, which is what you're seeing in the video, to me is just, it's mathematical nonsense. It's theoretical physics. It's not real physics.
Yeah, that's pretty much what I said in terms of, I'm not a mathematician, but the way it seems in my mind, in order to define what you've just described, i.e. things getting projected from further and further beyond your line of sight, up higher and higher to meet the horizon in perfect proportion. It's just ridiculous. You can't accept it. To describe it mathematically would be a huge undertaking. You then throw into the mix Ireland on the left-hand side. The right-hand side is still very contentious because it's shrouded in your usual flat earth grey area that is refraction. On the right-hand side of the image, there's a band of refraction that's covering and masking certain things in the picture. The left-hand side, because refraction is varied, we do have weather that's different in different places. You've got this whole, lucky for us, left side of the island, which is considerably further away, that's crystal clear, pretty much. You can look down the coast and see these things getting further and further and further and further away, which is lovely for us to be able to point out that we've got this extra bit of land with a lighthouse-shaped thing in exactly the same place a lighthouse should be, that's between us and something that's about 145 miles away, Ireland. And this is the bit that the Globers don't really want to attack. They want to stay at the north end of the island where it's all shrouded in mystery, like all the other flat Earth photography we normally see. It's just luck or judgment, whatever you want to call it. Personally, I'd just call it a clear day. Anthony's got a representation of our world. That's what the world really looks like. Unless you want to accept that landmarks further and further and further down the coast are being projected up higher and higher and higher to meet your eye level. In other words, we have holographic representations of what the land should look like, and it coincidentally looks exactly the same as if you got in a boat, travelled to about 10 miles off the coast, and saw it with line of sight. It just happens to look exactly the same. That lengthy of an explanation in and of itself should tell people something's not quite right. Whereas the flat Earth explanation, as you put it so succinctly, we see it because it's there. It's the end of the story for us. Nice and simple. So we can get away with calling people fantasists when they have to be able, in the first instance, to regurgitate this nonsense. And probably 8 or maybe even 9 times out of 10, people can't. They have no way of regurgitating that amount of nonsense back to me so that I understand what is necessitated for them to accept that they live on a sphere when they look at that image. Most people can't do it. They can't parrot what the rumpus will be detailing right now in his 45-minute presentation. It's beyond most people's comprehension because it's beyond bullshit.
Well, it's not supported by evidence. It's not supported by fundamental facts, is it? So it requires belief. So for me, it is religion as we stand at the moment, because it's the religion of the holographic God, isn't it? From what I can see, it's, that's the reality. They believe that what they're seeing is not there, as you allude to. So fundamentally, from me being just scientific about it, there is no evidence. So it is a religion. That's not to say they're wrong. A religion could be right, but by definition for me, what they're postulating and stating as true is a religious belief, not a scientific belief. And that is demonstrated fantastically and evidenced in the photographs.
Yeah, and as you say, people are entitled to their beliefs. It's not that we want to say to people, you're not allowed to believe you live on a spinning ball flying through space. It's just not realistic to actually, go out and then assess things in your surroundings and compare them to what it would be to live on a sphere. That's just not the world we live in if you actually look at it. And that's why I use the term obviously and observably. The world is obviously and observably flat. And if you stick your head in a book and read about the physics of spheres, then yeah, you can get to an understanding of what it would take. It's only when you go out into the real world and start comparing these things that you start to realise that it doesn't match. There is no match with what they tell us. And the worst part of it is there's people like Mick West who want to shroud that grey area in even more mystery with a dash of deception. And that's precisely what things like the Metabunk calculator are. It's bad enough that we don't live on a sphere and we're doing, the mathematics of what happens to our line of sight on a sphere. That's bad enough. But to then manipulate the rules of gravity for the sphere that you say we live on so that it matches slightly what we observe or is pushed more into a grey area would be a more accurate description, to me is an outrage. It really is. Because that's when, if people say, well, who's perpetrating this deception? There can't be thousands of people that know. Well, no, but there are certainly examples of people out there who are definitely trying to deceive you. They are fundamentally altering the rules of the ball so that you don't notice that you're not on a ball. That's the bottom line here. And that to me is frustrating beyond belief, because I can now say to somebody, well, if you want to know who's deceiving you, here's an example. Here's a guy who's literally going out of his way to deceive you. He's not representing the physics and mechanics of a ball accurately in terms of what it takes to be a ball and the reasons and whys and wherefores of why it is a ball in the first place. Those are essentially tossed out the window because it doesn't quite look right. So therefore they'll represent it completely differently in this diagram, basically to deceive you. Because if you saw it how it was actually represented in the physical world, according to them in the heliocentric model, you would much more swiftly recognise that it doesn't replicate reality in any way, shape or form. You know, you've only got to get in a plane, take off, and notice that the ground isn't falling away from you. It's just not. The horizon does rise with you. Now, that's why people use attitude meters. That's why you have a false horizon. And yes, you can go talk about the very small declination that happens through perspective, but this is easily accounted for. You know, it's very well documented. People who fly know. It doesn't change where the real horizon is, and you have to point your aeroplane at that in order to fly level. It's as simple as that. There is an eye-level horizon, whether people like it or not. But when you state these things, it's when you get huge amounts of ball earth, people calling you a shill, telling you you're a disinfo agent. It's like, you can't change reality. It doesn't matter how your depictions want to slightly trick people into thinking it's not quite the way you think in terms of the mechanics you're taught in school about how the ball actually works, how gravity works, for example. These things, they can be twisted to deceive you. And that's maybe, hopefully, the thing that will happen more and more and more going forward in Flat Earth, that people will point out these deceptions and the audience will start to recognise it. Even the people without critical thinking, if you say it and point it out with enough evidence to back it up, even the people without critical thinking will eventually start to recognise what's going on around them, and that's that they're being deceived. We don't live on a sphere.
No, I'm with it. I would thank the Ball of Summit. They do add a lot of really, really over the top, obviously, but it's very, very useful in terms of, from an objective point of view, watching the stuff, to actually not just listen to your opinion, but to listen to other people's opposite opinions and then listen to them be dissected. You know, and that, you know, it happened, it swung to and fro as for bits, didn't it? But it was a very good thing to actually, when you took out a lot of the fluff, to actually see how each little pixel almost was being identified and verified. And a good example of the detail you went to was when you had that guy on the other day with his ideas, and literally the lack of detail and the lack of co-lining up 1, 2, 3, 4, and 5, where he just got one thing and he thought that was sufficient. The actual level of detail that had gone off in those debates, Nathan, really does, for me, validate when you guys say that's there and that's that point and that's that point. All the data to argue against it has already been done. So it adds a real weight to the statements you make with the pictures that maybe people don't first recognize when they start to argue against it. You know, what was his name that was on the other day? You know, you were very kind to him and you didn't take the mic or anything. You were very patient, letting him go through it, but you already knew what he was going to say. And
well, I did lose my temper with him a little bit towards the end. Rene, his name was. But Rene, yeah, I mean, in essence, what he had done is he'd picked Morgul Lighthouse, which everyone's in agreement over, but then triangulated his position with a ridge on the right-hand side of the image, part of the image that I said is shrouded with, or riddled with dirty air, whatever you want to call it. There's loads of different terminologies, but basically there's stuff missing from the picture that should be there and is not on the right hand side, and he's triangulating with something that's highly contentious. So something that 50% of the people I speak to say is Ireland, 50% of the people say is the Isle of Man. So if it's in contention, you can't really use it to triangulate. But as soon as he did, we kind of, you know, all three of us, me, Ranty and Anthony, all rolled our eyes simultaneously because we've done it. We'd done exactly the same thing with the rumpus at that scale and saw where it had failed. So we let him walk us through the steps until it failed, and then he did exactly the same thing the rumpus did, was change his mind about the thing he was targeting and then move it. It's like, we've been through all this, we've seen this fail, we know why it's failed, you've got the scale wrong. And as much as this maybe hasn't been displayed by Chris, because, you know, to get his model as accurate as he has, he's gone to efforts that, you know, he's a fairly modest guy, so he's not going to go into the detail and the nth degree level that he's gone to get that model so accurate. I mean, one of the things he actually did was he took Ranty's composite completely to pieces and took every single screenshot and angled it so that it represented the arc swing of the camera. So it was, instead of just having a flat image that they're matching it with pixels, he's got it in a perfect arc, you know, at the focal length of the camera. So as he sweeps through on his 3D program, and it's got the model, the wireframe model of the Isle of Man, say, in the foreground if he's got it turned on, but you can then see the pictures literally arcing round exactly as the camera would have taken them. He's then gone to the effort also of putting into the program the exact details and information of the focal length of the exact camera, the P900, so that you can get the parallax correct as he swings on the tripod at full zoom, or whatever zoom the camera is at. So he's factored in all of these different things to make the model basically as perfect as it can possibly be when he's making his assessments. So, you know, being the modest guy is, he is occasionally put on the spot and say, people will say, well, how accurate is it? And he'll go, to within a foot. You know, it's accurate. And when people say, is it Ireland? Yes, it is Ireland. It can't be anything else. This is an accurate representation of reality. It all matches up. And then when you see Ranty doing it with their own tools, i.e. taking you to Google Earth and saying, look, if you get it as close as you can so you can pick out details in Google Earth, you can match those details with the picture. You know what you're looking at because it matches perfectly. And till now, we've had literally no one to come along and say, here you go, this is how it actually matches. Here's my comparison, because they won't ever get it to be better than perfect. We've matched it, or Ranty has, and Chris has. You know, and from there, you can triangulate exactly where everything is and say, without question, we're looking at Ireland on the left. You know, again, I keep reiterating this, on the right, it's contentious. You know, we live in quite a fractal world. Not quite a fractal world, a fractal world. So in terms of the way the geology of the land lies, if you line up with something, there's a good chance that there's something going to be in the distance that looks almost identical and lines up perfectly. You know, if you look at the LiDAR map from above, it just looks like a brain. You know, like if you took a cross-section through a brain. It's exactly the same sort of shapes. But that facilitates being able to confuse things that are in the near and far distance, depending on, you know, how clear the day is. So based on this, you can't really triangulate with anything that looks like a hill, which is why, I got quite angry when people trying to match stuff on Peak Finder, because if the parallax is pushed out, you haven't got a clue what you're looking at. You can only match it up with landmarks. And through a process of elimination, probably 80 hours of live debate and probably another 1,000 hours of man hours on top of it just on our side, going through all of this stuff, you end up at a nice conclusion that you can declare to people. It's fairly simple, it's obvious and observable, the Earth is flat, here's Ireland at 145 miles, here's Lagness Lighthouse at 51 miles, here's Morgold Lighthouse at 31 miles. It all looks exactly as it would on a flat plane, because it is. Unless you want to believe in holographic projections, or what's the comical one? The slightly looming, non-standard refraction hyena holograms, which is basically the bullshit sandwich you've got to accept if you live on a globe. So it's been a real pleasure going through that in itself, and it's led us on to conversations with people like you about things like curve calculators, and hopefully, you know, this conversation just in itself will lead people to some truth about the non-reality we are told we are living in. So we're coming up on about the hour mark, Adam. I know you've got a meeting to get to with Iron Realm. Was there anything you wanted to get in or plug before we round out this show?
No, you've been very kind with the plug-in, mate. All I would say, is like I said at the start, that's a piece of maths I've done. I'm open for criticism. I invite it. Any feedback, if anybody thinks it's wrong somewhere, if we can tweak it, you can see any holes in it, I'd appreciate the feedback, whether that comes through me. You can contact me at Larcheo Red, that's LARCHEORED on Twitter, or by the ironrealm.com website and get us there, or through you, Nathan, or whatever. I'll be reading the chat or anything. I'd really appreciate any feedback if you think there's something we've done wrong. So yeah, thanks for having me on, mate. I appreciate the opportunity to put it out there, and hopefully it is of some use to somebody in the future.
Definitely. Can you give us one last plug to the Iron Realm? Not the Iron Realm. Sorry, the Ironworks on TFR. Can you just plug that again and give the times maybe for the UK audience?
Yeah, I'll give it a shot. So that's the Ironworks. That's on Truth Frequency Radio, and that's on at 10 a.m. in the morning till 12 lunchtime on Tuesdays and Fridays. And then on a Friday, obviously, that's followed by the Friday Night Fringe cast with all of us guys on 10 o'clock ish start time on the Friday. But yeah, so the Ironworks show is hosted by Josh and Walt. So they're guys with the more traditional radio DJ voices.
I'm not sure which one it is, but I can see either Josh or Walt currently in the chat under the Iron Realm Media avatar. So if you are currently in the live chat, be sure to click on Iron Realm Media's logo and subscribe to their channel for some excellent content. And indeed,
while you're there, Nate,
as well.
One last big shout out. We're less than 30 away from the 1,000 now. We've got the hours. So if there is anybody out there that would be kind enough to subscribe to take us over that 1,000, be most appreciated.
Yeah, definitely. There's no reason why it shouldn't be. There's at least 100 people watching, 105 by my current reckoning. So be sure to click that Iron Realm logo and subscribe now. Hopefully you can get Iron Realm Media over 1,000 subscribers before the end of the day. And with that, I'm going to say a massive, massive thank you to you, first and foremost, Adam. Thank you very much for being here. It's been a real pleasure.
Cheers, pal. Thanks for having me.
And of course, a massive, enormous, huge thank you to all of the live audience for tuning in. Be sure to like, comment, share and subscribe. I've been Nathan Oakley and I will see you all in the next video.